Hi and welcome back to my channel. Today we're going to look at the National 5 2018 paper, section 1, which is multiple choice. If you haven't already tried these questions, pause the video now, go to the SQA website where you can find this past paper. The link is in the description box below. Question 1. Which of the following changes would not speed up a chemical reaction? When you're trying to speed up a chemical reaction, you're trying to increase the number of collisions between particles or increase how hard they hit each other when they do collide. To do this, you can increase the temperature, increase the concentration, or add a catalyst. When changing particle size, you would decrease the particle size as this would increase the surface area and therefore the area available for collisions to take place. So A will not speed up a chemical reaction. Question 2. Which line in the table identifies the correct location of a proton and electron in an atom? Let's draw a helium atom. So helium has 2 protons and 2 neutrons, and these are found in the centre of the atom in the nucleus. There's then an energy shell around the outside where we have 2 electrons. So here in the centre we have our protons and they are in the nucleus, and then around the outside we have electrons and they are not in the nucleus. So looking at the protons, the only answers that we can use are A or B, so we can ignore C and D. And then the electrons are outside the nucleus, so B is the answer. Question 3. Which of the following elements does not exist as diatomic molecules? There are 7 diatomic molecules that you need to learn, and you can remember these using a mnemonic to help you. So the first letter of each word represents one of the diatomic elements. So have is for hydrogen, no is for nitrogen, fear is for fluorine, of is for oxygen, ice, iodine, cold, chlorine, and beer, bromine. If we have a look at the answers, we have oxygen, bromine and hydrogen as diatomic molecules, and then B, helium, which is a noble gas, is not diatomic. Question 4. The shapes of some molecules are shown below. So we have tetrahedral, which has a central atom joined to 4 others, trigonal pyramidal, which has the central atom joined to 3, angular is joined to 2, and then linear just has 2 atoms joined together. So we're trying to find the shape of a molecule of hydrogen bromide. So if we write out the formula for hydrogen bromide, if we start with the 2 elements, write their valencies underneath and cross them over, the formula is HBr. So for this we have 1 H atom joined to a Br. So this is closest to a linear arrangement. Question 5. Which of the following elements forms an ion with a single positive charge and an electron arrangement of 2,8? You may wish to use a databook to help you. The page in the databook you want to look at is page 6, which has electron arrangements. So if we have 2,8, and we know that this is an element with a single positive charge, we call this X+. If we were to add the electron back in, which has been lost to cause the positive charge, we would have an electron arrangement of 281. We'd also have an atomic number of 11, and if you look that up, you'll find that that is sodium, which is A. Question 6. Which line in the table shows the properties of a covalent network compound? So a covalent network compound has many covalent bonds which need to be broken when you break down the compound through melting. This means that we'll have a high melting point, such as B and D. As this is a covalent structure, it will never conduct electricity, so it will be D. You can work out the bonding in the other three answers as well. So A, with the two low melting and boiling points and no conductivity, is covalent molecular. B, with the high melting point and conducts electricity as a liquid, is ionic. And C, where it conducts electricity as a solid and a liquid, will be metallic. Question 7. 0.1 moles of sodium hydroxide was dissolved in water and the solution was made up to 250 centimetres cubed. What is the concentration? So for this we want to use the equation concentration is moles divided by volume. Now you have to be careful that your volume is in litres. You're given the volume in centimetres cubed, so you need to divide that by 1,000 first to get 0.25 litres before using the two values given in the equation. This gives you a concentration of 0.4 moles per litre. Question 8. An alkaline solution contains what? So let's start by looking at water. Water is made up of H2O molecules, which break up into hydrogen and hydroxide ions. Water is neutral because both of these ions are present at all times. When you have an alkaline solution, you have more OH minus ions than you have H plus ions. However, the H plus ions are still present. So we can ignore A, only hydroxide ions. Then we have B, more hydroxide ions than hydrogen ions. This will be our answer. C would be an acid, where it's the opposite way around, and D would be water. Question 9. A student made some statements about the effect of adding water to an acidic solution. Identify the correct statement. So if we have an acid, we have H plus ions. We have more H plus ions than we do OH minus ions. And if you add water, then you dilute your solution. By diluting the solution, you will decrease your H plus concentration. This means that your pH will rise to be closer to 7. So A, the pH of the solution will remain the same, we've just seen it will change. The pH of the solution will decrease. That would happen if you increase the concentration of acid. The hydrogen ion concentration will decrease. This is our correct answer. 10. A shortened structural formula for a compound is shown here. Which of the following is another way of representing this structure? So first of all, we need to draw this structure out so we can compare it to the answers given. So we're going to take each part of the shortened structure and add the lines back in for the bonds. So we have CH3 joined to CH2, which is then joined to a CH. The brackets mean that we have a branch. Then we're joined to another CH with another bracket, so we have a branch of CH3. Then CH2, CH2, and finally CH3. So if we have a look at each of the structures, so in this first structure, we have branches on the second and the fourth. We have branches on the third and the fourth. In this structure here, we have 6 carbons, whereas here we have 7. In this structure, we have both branches on the third carbon. Our branches are on the third and the fourth. And here we have a branch on the third and the fourth carbon. So you can spin the molecule around this bond here, which means that you would get the same arrangement that I've drawn here. Question 11. Identify which of the following is an isomer of this molecule here. So isomers are molecules which have the same molecular formula but different structure. So the first thing we want to do is to count up the carbons and hydrogens within this molecule so that we can write out the molecular formula. So we have C6H14. For something to be an isomer, we have to have the same numbers of carbons and hydrogens, so that's a good place to start. So for A, we have C6H12, so this cannot be an isomer. For B, we have C6H14, so a possible isomer. C is also C6H14, a possible isomer. And D is C5H12, so not an isomer. So now looking at B and C and looking at the structure. Another way that we can check isomers is to name the structure. So all isomers will have different names. So this structure here has 5 carbons along the middle. So it's based on pentane. And on the second carbon, we have a methyl branch. If we were to have a look at B, we can see we have 5 carbons along the middle. So pentane. And this time, counting from the right hand side, we have a methyl branch on the second carbon. So these two are the same structure, they've just been flipped over. And for C, we have 5 carbons, so it's pentane, and this time the methyl branch is on number 3. So this has a different name, therefore a different structure, so it's the isomer of the compound given. Question 12. Which of the following reactions takes place when an alcohol is formed from an alkene? So let's go through each of the types of reaction. So for A, hydrogenation, you would take an alkene and add hydrogen, and this will give you the corresponding alkane. B, combustion. You take an alkene and react with oxygen to get carbon dioxide and water. Hydration. You take an alkene and water, which adds across the double bond. So one of the hydrogens from water adds on to one of the carbons, and the OH adds on to the other carbon to give you an alcohol. Question 13. The systematic name for the compound above is what? So the first thing we need to do is to find the longest chain of continuous carbons. Though bear in mind that they can go around a corner like we have here. In this one we have 5 carbons. So this is going to be based on pentane. We need to number the chain from the end closest to the OH. And we can see that on the second carbon, we have the OH group. So we have pentan 2-ol. Question 14. Which of the following alcohols is the least soluble in water? So alcohols are soluble in water because they have an OH group which can interact with water. However, the larger the alcohol, the less soluble it becomes as the carbon chain gets longer. Here we have 4 different alcohols, so we just need to know how many carbons are in the chain. So for A, we have butane, which is 4, hexane is 6 for B, pentan is 5 for C, and for D, we've got propane, which is 3. So the least soluble will have the longest chain of carbons, which is B, hexane 1-ol. Question 15. A student set up an experiment to determine the quantity of energy released when a hydrocarbon burns. Which of the following diagrams shows apparatus which would produce the most accurate result? So this is an experiment that you have probably carried out in class. So to do this, you burn some alcohol or fuel within a spirit burner. The energy which is released is transferred to some water, and you see the energy change through the temperature rise in the water. Now to do this, you use a metal can as you get a better heat transfer rather than a glass beaker. And to stop any heat escaping to the outside environment, you use a draft shield. So B would be the best apparatus to use. Question 16. The ether 1-ethoxypropane, which is this molecule here, can be made by the Williamson reaction. Which of the following pairs of compounds would react together to produce 2-ethoxypropane, which is this molecule here? So if we have a look at this reaction, we have ethanol, which has the OH group, and 1-chloropropane, which has a Cl group, and they are reacting together to form this new compound. If we look closely, we can see that the H and the Cl are being removed, and then the O is joining on to the other carbon. So this means that for this to work, we need to have a hydroxy group and we need to have a chloro group. So if we first of all look at each of the reactants to see if we can eliminate any. In the first one, we have hydroxy and hydroxy, so this would not work. In B, we have hydroxy and chloro, which could work. In C, we have hydroxy and chloro, which could work. And then in D, we have chloro and chloro, which would not work. If we now have a look at the structure that we're making, we can see that this group here has joined on to the middle carbon, which means that in the chain of 3, we need to have our functional group in the middle to allow this to join on here. So we've got two options that we could join together. If we took B, then we would simply join the 2 carbons onto the end of the 3 carbons as we have in the first example. If we took C, then the H and the Cl can be removed and then the O can join on to the middle. So if we draw this out facing the other way, and if we spin this one on its side like it is here, we can take off the H and the Cl, and then when the O joins onto the carbon, we will end up with this structure here. Question 17. Information about the reactions of 4 metals W, X, Y and Z is given in the table, and we are to order them from most to least reactive. So we're reacting the metals with acid and with water. So first of all, if we look at the acid, the most reactive metal is going to have the fastest reaction with acid. So we have 2 options. We have X and we have Z, which both react fast with acid. We then need to have a look at water. So we only have one metal which is reacting with water, which is X. So X must be the most reactive as the others do not react with water. So X will be the most reactive. Let's look now at the opposite end. So we're looking for the least reactive. So none of the other metals react with water, which means we have to look at the acid reaction. W and Y react more slowly than X and Z, but Y is the slowest one. So that will be our most slow reacting metal. And then we need to order the other 2. We have Z and we have W. So Z reacts quickly with acid, so will be second most reactive, and W has a moderate reaction. This means that our answer is A. Question 18. The ion-electron equations for the oxidation and reduction steps in a reaction between hydrogen and oxygen are given below. What is the overall redox reaction? To be able to write an overall redox reaction, you need to eliminate the electrons. As we can see, we have 2 electrons here and 4 here. We need the electrons to be the same if we are to be able to eliminate them. So we need to multiply this first equation by 2. So we'll have 2 hydrogen, 4 hydrogen ions, and 4 electrons. That means that we can now eliminate the electrons and we can add together everything that is on the left-hand side and then everything that's left on the right-hand side. So we're looking for an answer which has no electrons, so we can eliminate A and D, and we have to have 2 hydrogen, 2 water, 1 oxygen on the left, 4 hydrogen ions and 4 hydroxide ions on the right. So B is the answer. Question 19. Which of the following metals, when connected to lead in a cell, would produce the highest reading on the voltmeter? You may wish to use your databook to help you. You want to look at page 10 of your databook, which is the electrochemical series, where you can find all of the metals listed in order, from most to least reactive. When you're trying to produce the highest reading on a voltmeter, you're looking for the biggest difference in reactivity between the two metals. So you need to find lead and then find which of these metals here is furthest away from lead on that table. When you have a look, you'll find that zinc is the one which is furthest away, therefore we produce the highest reading. Question 20. Which of the following salts would not be used as a fertiliser? So there are two characteristics of a fertiliser that we need. So the first is it needs to contain at least one of the elements of nitrogen, phosphorus and potassium. It also needs to be soluble. So ammonium chloride has the formula NH4Cl. Ammonium phosphate is NH4 3PO4. Sodium chloride is NaCl, and sodium phosphate is Na3PO4. So we can see that ammonium chloride has nitrogen, ammonium phosphate has nitrogen and phosphorus, sodium chloride has none of the three elements, and sodium phosphate has phosphorus. Therefore, sodium chloride would not be used as a fertiliser. Question 21. Which metal is used as the catalyst in the industrial manufacture of ammonia? All of these metals are used as catalysts for different reactions. So nickel is used in hydrogenation. That's where we add hydrogen onto double bonds. Platinum is used in the Ostwald process, which is used to produce nitric acid. Iron is used in the Haber process, which is used to produce ammonia, and rhodium is used in catalytic converters in cars. So C, iron, is our catalyst for the industrial manufacture of ammonia. Question 22. The diagram shows the path of two different types of radiation as they pass through an electric field. Which line in the table correctly identifies the types of radiation? So we have three types of radiation: alpha, beta and gamma. Alpha is the nucleus of a helium atom and has a positive charge. Beta is an electron, and gamma is electromagnetic radiation. So if we first of all look at path X, which is this one here, this is being attracted to the negative plate. This means that whatever this radiation is must have a positive charge. So the radiation with a positive charge is alpha. So that means we can ignore B and C. If we look now at path Y is going straight through the two plates undeflected. This is because this must be gamma, which has no charge. So our answer is D, alpha and gamma. 23. Metallic bonding is a force of attraction between what? So let's go through each of these in turn. So A, a shared pair of electrons and two nuclei. That describes a covalent bond. B, negative ions and delocalized electrons. Does not describe bonding. Negative ions and positive ions describes ionic bonding. Positive ions and delocalized electrons. This describes metallic bonding. Question 24. The type of reaction represented by this equation is what? So neutralization occurs when you neutralize an acid. Precipitation happens when you have two solutions which produce a solid. Addition is where you have something with a carbon-to-carbon double bond and you add something on. And redox is where you have your oxidation and reduction, so it involves electrons. Looking at this reaction here, we have 4 aqueous species in the reactant side, and they are producing a solid and 2 aqueous. This is a precipitation reaction. Question 25. A student prepared a sample of copper sulfate crystals by reacting excess copper carbonate with acid. Which line in the table shows the correct order in which this experiment would be carried out? So the first thing you need to do is to react your excess copper carbonate with acid. So Y will be step 1, where you can be seen adding in the powder into the acid. You're reacting excess copper carbonate, which is a solid, which means you'll still have solid left over. So step 2 will be Z, where you have to filter that. And then step 3 will be X, where you evaporate off the water. So the order will be Y, Z, X, which is D. Thank you for watching my video. I hope that you found it helpful. Please remember to subscribe and ring the bell for notifications of new videos. Follow me on Twitter at Miss Adams Chem and Instagram Miss Adams Chemistry for updates on videos and flashcards. Bye for now.